Hi, my display isn't working yet. There we go. Awesome, yes. Hi everyone. So my talk is gonna be about the Broccoli build tool. I'm Joe, I'm the author of Broccoli. And my talk has two parts. The first part is kind of a low-level introduction to what Broccoli actually is, what motivates it, how to use it, and we're going to talk about the architecture a little bit. And part two is going to be a bit more high-level about the ecosystem, how Broccoli fits in with other tools, and where we're going with it. So some background first, like what motivates us to write a build tool? Just a quick show of hands. Who in here has used Rails and the Rails asset pipeline? Like CoffeeScript and stuff like that? Yes, a couple people. Who in here has used Grunt to build JavaScript and CSS apps? That's a lot of people. Awesome, yes. So when you have like a regular-sized app, what tends to happen is you have like CoffeeScript files or something, some pre-compilation for your JavaScript, and templates, let's say handlebars or something that you compile. And then you have a concatenator to concatenate all the JavaScript together into one big file. You might also have Sass or a similar CSS preprocessor. And at the end, you probably have minifiers. So you have this sequence of build steps. And what many of you have been doing is using Grunt for that. It's, I think, the most popular tool right now to define build processes. So you want to edit a file and then reload in the browser. So what a lot of people do is use a plugin like Grunt Watch. So whenever a file changes, whenever you save, it notices the change, rebuilds your app, and then you can reload in the browser. That works great at first, but if you work on a medium-sized app with a medium-sized team for just a couple months, what tends to happen is that the rebuild takes 10 seconds at some point. So you edit a file, save, Grunt picks up the change, it rebuilds, and rebuilds, and rebuilds. It's really slow, and you're just sitting there, right? And then you reload, and then it's done. So this is a really big problem because that edit, reload cycle is a really important part of our feedback loop as developers, right? We do this like hundreds of times a day, and anything interfering with the speed of that is going to make development a lot less fun. So that motivates, that's what motivates creating a dedicated build tool like Broccoli. I'm personally also a big fan of the Rails asset pipeline, which does a good job of solving the performance problem, but it's tied to Rails as a backend. And clearly in JavaScript and CSS land, we want to have something that is backend independent. So let me show you how to actually write a build definition in Broccoli. So I have kind of a pre-recorded live coding demo. Awesome. So here we have an app with a lib directory with some CoffeeScript files in it, and a public directory with some static files, a vendor directory with jQuery, and a styles directory with Sass. So that should look pretty familiar to you. This is like a simplified example of many real-world apps. And we're going to derive the build definition for this app. So I'm going to skip the require calls on top. And we're going to just start by exporting the public directory. And what this is going to do is, when you run Broccoli serve now, it's going to serve all the files in the public directory. And when you run Broccoli build dist, it will copy all the files in the public directory over to the dist directory. So that's pretty unexciting. let's now take the files from the lib directory and copy them into the output. So we call the merge trees function, the plugin, on the lib directory and the public directory. And that is going to return a virtual directory, a virtual tree, that contains the files in the lib directory with the files in the public directory copied on top. But we have CoffeeScript files in the lib directory, so let's run the CoffeeScript compiler on it first. So we call filter CoffeeScript on the lib tree and get a new virtual tree, libcompiled, we're going to call it. And then instead of lib directly, we pass in libcompiled into merge trees. So now, what filter CoffeeScript does is it takes the lib directory, it passes through all the files except for .coffee files, and .coffee files get replaced with their corresponding .js compiled files. But we also want to concatenate all the files. We don't want 10 different JavaScript files in the output. We just want to concatenate everything. So we're going to use a very simple concatenator. We're going to call it on the libcompile tree. Tell it to take all the JavaScript files and output a single JavaScript file. And the concatenator is going to return a tree that contains one single file, app.js, inside a single directory, assets. So even though we kind of conceptually, the concatenator, actually, we think of it as returning one file, what Broccoli sees is a tree which contains one file. And then instead of libcompiled, we merge in app.js at the bottom into the output. Let's add jQuery from the vendor directory. So we're going to create a new virtual tree called JavaScripts. And we're going to copy the libcompiled tree on top of the vendor tree. We're just going to copy them over each other into one virtual tree and pass that into the concatenator. And we want to make sure the jQuery file comes first. So jQuery.js and then the rest. Awesome. And finally, we are going to add the Sass file. So we call the still playing. Come on. There we go. We call the compile Sass plugin on the styles tree. We tell it to pick up the app.sass file and output one single app.css file. And then we merge that into the output. Okay. And that is the entire build definition for our app. Let me show you again what we just did in more visual terms. So to visualize this Brock file, I want you to notice that the primitive that Broccoli thinks about is not a file, it's a tree of files. So every rectangle that you see here is an entire directory, if you will. So we take the lib directory, we run it through the CoffeeScript filter, which gives us a libcompiled tree. We merge the libcompiled tree and the vendor tree, get a merged JavaScript tree. We run the concatenator to get a app.js tree. Then we run Sass on the styles tree to get an app CSS tree. And finally, we merge everything into one single output tree. So just a point of caution, Broccoli is 0 point. It's beta software, so there's going to be some API changes, but in general, it's reasonably stable. You can use it if you want to. And I'm hoping that it will hit 1.0 reasonably soon. So now that you've sort of seen how Broccoli works, I want to take a to do a quick interlude and talk about some of the architectural stuff that has gone into Broccoli. So when I started working on Broccoli in November 2013, I just set out to very naively kind of solve two problems. The first one being rebuild speed, like making a build tool that is fast, and the second problem being I wanted the build syntax to be composable. So as we saw earlier, we didn't have to maintain any temporary directories for the intermediate build outputs. We could just chain all the plugins together. And I think that's really important as build definitions grow more complicated. And so I kept working on Broccoli, and I kept having conversations with other people who were working on build tooling, who were working in this general field of like grunt-based tools, like things just who were interested in how to make building work for web apps. And I want to zero in on one really sort of, in my view, interesting technical thing in Broccoli about how it manages to do fast rebuilds. Who of you has used the make tool, the Unix make tool? It's a bunch of people. So just to kind of recap, make is a 30-year-old tool, I guess, decades old, that lets you assemble build definitions, and it figures out which file to rebuild based on the dependencies of each file. For tools like for compilers like CoffeeScript, that's very simple. When every .coffee file corresponds to one single .js file, you know exactly when to rebuild the .js file. That's very straightforward. But there are times where figuring out when to rebuild which file is more complicated. And basically, all kinds of import statements are our enemy with regard to these dependencies. So when you have like // equal jQuery, like in the Rails asset pipeline, or import bootstrap in Sass, or import $ from jQuery, that's the upcoming ES6 module syntax in JavaScript. When you have statements like that, what happens is that one output file depends on multiple input files. And Make's approach is making a dependency graph. To show you what a graph like this looks like, let's say we have an output file application.min.js. Let's read this from the bottom. We know that we need to rebuild application.min.js whenever the intermediate application.js file changes. And that file in turn comes from our application.js file, which requires jQuery. So it comes out of a concatenator. And we need to know that if jQuery changes, we need to rebuild application.js as well. And actually, application.js doesn't directly come from the file system, but we have a .coffee file, which needs to rebuild into application.js whenever it changes. So make make type of tools, build this dependency graph. Basically, for every file, you specify explicitly or implicitly which files they depend on. And when you request the application.min.js file, it's going to check the input files, which in this case is application.coffee and jQuery.js, and see if they're newer than application.min.js. And if they are newer, it is going to rebuild application.min. But that requires that for every output file, we have the complete dependency graph where each file comes from. So every plugin, the minifier, the concatenator, the CoffeeScript compiler, needs to tell the build tool what the dependencies are. And that can be pretty tricky. If you've used make, then probably you've typed make clean before to clean up your project. And the reason why we keep doing that, we change something and we run make clean just in case. Just tear down all the build products and rerun the whole thing. And the reason why we run make clean is that we don't trust make to do its job properly. We don't trust these dependency graphs to be 100% correct. So we run make clean just in case. We wipe the intermediate build outputs and rebuild everything from scratch. So let me show you some examples why building these dependency graphs is kind of tricky. So let's say we are doing this merge tree operation that we did earlier. So we are copying the vendor tree and the app tree into one single merged tree. Now, what files does main.js depend on? Well, clearly app/main.js. And jQuery.js depends on vendor/jQuery.js. That's where they came from. So whenever one of these input files changes, the corresponding output file needs to be rebuilt. But there's a tricky part here. Let's say we add app/jQuery.js. That's going to overwrite vendor/jQuery.js in the output. So now that this file has come into existence, we need to rebuild the output jQuery.js file. And that's really surprising in a way. Like, we had a fairly simple copy operation, but expressing the dependencies for each output file is surprisingly tricky. As a similar example, let's say we run a concatenator on all the JS files. So we concatenate foo.js and bar.js into everything.js. So everything.js needs to be rebuilt whenever foo or bar change. But if we add a new file, like baz.js, we still need to rebuild everything.js. So somehow, our output file depends on input files that don't even exist yet. And that makes the whole dependency graph thing very unpleasant and very brittle. You're having to think about these edge cases all the time. So what Broccoli does instead is it turns this approach on its head. Rather than figuring out whether output files are up to date, whenever any input file changes, it reruns the whole build process, everything. So when one file in any of these directories changes, it's going to rebuild everything. How can we make this fast? So the trick is that every compiler, every arrow that you see in this graph is responsible for being fast. We want the whole rebuild to be instantaneous. So instantaneous for humans means about 200 milliseconds. So we have a 200 millisecond budget to rebuild the whole thing. For compilers like CoffeeScript, the first time you run them, let's say you have 100 input files, 100 CoffeeScript files. The first time you run it, it's going to compile all those files, and that's going to take a while because compiling CoffeeScript is kind of slow. But then, next time you rebuild, if one of these files have changed, Broccoli is going to kick off the entire thing from the beginning, but the CoffeeScript plugin is going to be smart. It's going to notice that 99 of the files haven't changed, and it's going to pull their build output from its internal cache. So the one file that has changed, it's going to rebuild, and the 99 files that haven't changed, it just symlinks into place from its internal cache. And that way, the CoffeeScript compiler ends up being very fast. So this is a way to make, if we can make every compiler very fast, the whole thing will be fast. This in particular means that we don't have to figure out the dependency graph for parts of the build step that are very fast anyway. So for example, for merging files, for merging libcompiled and vendor, that's an extremely fast operation. That's just symlinking some files into place. It takes like 10 milliseconds in practice. So we stay well within our 200 millisecond budget. So we can just redo that every time we rebuild. We don't need to cache that. We don't need to figure out, we don't need to know which output files depend on which input files. But we just naively rerun the entire thing every time we rebuild. This makes writing compilers a lot simpler, because some things that are expressible in 5 lines, like merging trees, stay expressible very simply, and we're not having to worry about communicating to the build tool which output files depend on which input files. I think this general approach looks pretty similar to the direction that something like React.js is taking with regard to DOM bindings. So the general approach of, instead of figuring out backwards when something needs to update, going forward and making sure it's fast. So I thought that was a very interesting approach, and I'm sure we're going to see this pattern in more places than just build tools. So for part 2, I want to talk about how Broccoli, I want to sort of go a little higher level and talk about how Broccoli fits into the larger ecosystem of tooling for making web apps. Just to clarify this point, Broccoli doesn't directly compete with Grunt. Grunt is a great task runner, and there is in fact a Grunt Broccoli plugin that lets you plug Broccoli into Grunt. And what I want people to do is take Broccoli for the core build pipeline, the actual compiling, and then use a tool like Grunt to kick off Broccoli. But Grunt can also kick off other things like generating scaffolding or running the tests or deploying. So Grunt is a great task runner. We just shouldn't abuse it as a build tool. And I think the core build pipeline should be done by a dedicated tool like Broccoli. But there is no need to stop there. So having a sort of conventional Grunt setup that uses Broccoli at its core is nice. But clearly, you don't want to write your complete build definition every time you start an app. A typical sized app has maybe 100 lines of fairly dense build definition code. There's a surprising amount of things that need to be shuffled around, compiled, like tests going here, production code going there. There's a surprising amount of complexity. And I don't think it's reasonable to expect people to come up with their own build definitions every time they write a new app. So while having conventions is nice, it would be even better if we had tools that just kind of provide this stuff for you. And my big role model in that regard is Rails. If you create a new app with Rails, typing this into your terminal, you get an entire Rails app scaffolded out for you. You can just start filling in code. But all the libraries are set up for you. The Rails asset pipeline for compiling your JavaScript and CSS is just set up for you. You don't need to think about anything. And I think that's very powerful. And that's kind of how I want people to use Broccoli. Not by using it directly, but by using other tools like, in the spirit of Rails, that give you a complete stack for your app, and that then use Broccoli internally. And in fact, I would really like to see at some point a plugin for Rails for Broccoli to replace the Rails asset pipeline. One tool that I think is very cool in this vein is Ember CLI. Do any of you use Ember at all? Can you show of hands real quick? Any Ember users? Half an Ember user over there. I want to give you a very quick demo of what Ember CLI does. And I don't want you to pay attention to the technical details. The important part is not the coding part of setting up Ember here, but think about what you could do with a tool like this for your preferred framework, for your preferred environment. What if we didn't have conventions to assemble web apps, front-end apps, like these grunt files that tend to be pretty large? What if we had a default stack? So think about like what if we had like an Angular CLI type of tool? So let me give you a very brief demo. Just replay this very quickly from a previous conference. Will it play? No, it will not. At all. This is disappointing. There we go. Awesome. Okay. So we use, similar to Rails new MyApp, we use Ember new to generate a new app. And it generates a bunch of files and it installs a bunch of things. We're going to skip over the networking. There we go. Packages are being downloaded. Okay. And if we cd into this new app that we generated, we see a regular app structure similar to what many of your apps probably look like. So this is all generated for us. And internally, this uses Broccoli. But all the Broccoli build definition stuff is already generated for you. And we can now start the server, which internally uses Broccoli, and open it in the browser. And there we go. Let's generate some stuff. So this thing comes with generators, a bunch of generators. So the learning curve for this is much easier than going to the documentation and figuring out what to do. Where are we? The video is not liking me today. All right, so we have a bunch of generators that we can use to generate models or routes and stuff like that, similar to how Rails does it. So let's generate a new route. Fill in some code, fill in some code. All right. And it loads immediately in the browser. We can edit some stuff. Okay. And we can even run tests. And now that we have written a very, very tiny application, and because there's now a tool that controls the entire stack, it's not an ad hoc thing, an ad hoc grunt file that compiles your files, but it's a standard stack. So now we can exploit this fact that we own the entire stack, the entire build stack, and have a tool that deploys this to a platform as a service provider. So there's a new thing called DivShot, which is kind of like Heroku for static apps. So we're going to deploy this app now. And we're just going to follow the installation instructions here. Install. Okay. And generate the configuration and push. And now we can open it in the browser. And it's working. So we went from 0 to deployed app on the internet in 5 minutes. And I think that's very powerful. This kind of stuff is enabled by having tools that manage the entire process, rather than just conventions for assembling things. So this is something that I'm personally very excited about. These kinds of use cases are the primary reason why I wrote Broccoli in the first place. I don't really anticipate people using it directly, though you're welcome to, and I think it's a great build tool to use directly as well. But it would be even better if we just gave people great build experiences without them having to think about it. So maybe in the future we can have something like Angular CLI or React CLI. And just as a warning, Ember CLI is very much alpha. Many things are changing, and some things that it uses under the hood, like JavaScript ES6 modules, are still in draft and might change. But I know some people who are using it for production apps, so that's very cool. All right, so let's talk about what we get in the web space building on top of this. Something that motivated writing Broccoli is enabling better code sharing. And that's maybe not so obvious at first why you need a build tool for that. So obviously, when we want to share compilers, it's important that we have a common build tool, a common interface to just take a compiler, plug it in, and it works without having to manually wire things up. So it's good for sharing compilers. And also with something like Ember CLI, like you saw, because we now have a predefined app structure, we can now share generators. So it's now possible to distribute generators for other people, for your library, and say, if you want to get started using my library, here's a few generators that generate a few files for it. Also, having a well-defined build process is important for components, for distributing components and libraries. The reason is, if you add a package package to your application with Ruby or Python, when you say import package, it knows where to find it. It adds your package to the load path, and it searches for the package name when you say import, and it knows how to pick up the source files. But we don't have such a thing for JavaScript, really. JavaScript, as of now, doesn't have a first-class notion of module imports. This is changing with ES6 modules, but that's still not enough to write an app that when we write an app that goes to the browser, we still need a build step that concatenates all the files, that follows all the imports, concatenates everything into a big bundle, and then delivers it. And until we have that, it's very difficult to share code in a way that is easy to pick up. So what we're doing right now most of the time is we just distribute .js files, and you kind of copy them into your projects, and then you manually concatenate them. And it's really cumbersome, right? And we would like to have the same experience that we have with something like Ruby or Python or Java in JavaScript. And having a unified build process is a first step for that. And all the stuff that is built on top of that, like ES6 module transpilers that parse these import statements, that's what I think is going to enable code sharing. So this is the ES6 syntax. This is JavaScript. And right now it doesn't work in browsers yet. You would have to use a transpiler. But this is really exciting, I think, for making libraries more easily distributable. And we also want a package manager. So my definition of the problem would be, we want Ruby gems plus bundler for the web. That is to say, a central package registry and a tool that figures out, given a bunch of versions that you want, given a bunch of version constraints, that figures out which dependencies to load and how to resolve any conflicts. We kind of have some of this in NPM and Bower, but both tools are don't yet have solve all of our problems that we would like to have solved for web, JavaScript, and CSS apps. And so I'm really hoping that at some point somebody will come around and write a Ruby gems plus bundler equivalent for JavaScript and CSS.